Hello, my name is Daniel Nenni, founder of SemiWiki, the open forum for semiconductor professionals. Welcome to the Semiconductor Insiders podcast series. My guest today is GP Singh, CEO of Ambient Scientific. With over 20 years of experience, GP has played a pivotal role in shaping the industry, driving 50-plus chip tapeouts, including game-changing advancements at FinFET technology nodes. Now, as the CEO of Ambient Scientific, GP brings together hands-on engineering expertise and visionary leadership with more than 50 patents and 5 publications to his name. Welcome to the podcast, GP.
Thank you very much, Daniel. Thank you for inviting me. It's an honor.
Yeah, it's great to meet you. First, can you tell us what brought you to semiconductors?
So, Daniel, right from beginning, from my engineering college days, I was extremely interested in hardware in general. And that led me to computer design, computer system design in my first job that I did for 2 years. And then that led to the core of computer, which is the chip, and in particular microprocessor. So a couple of jobs down the road, I ended up working for a company called Sun Microsystem, a great company, and where I got the chance to work on UltraSpark microprocessors. And since then, I got hooked to it. So that's my story about getting me in semiconductor.
Yeah, that's very interesting. Why did you found Ambient Scientific? What's the value proposition here?
So, Daniel, the Ambient Scientific story is actually far more personal to me. After Sun Microsystem, I worked for a company called Wave Computing. Wave Computing was working on an AI chip, and the competition was NVIDIA. And we were able to develop a pretty competitive chip. While working there, I had a personal tragedy with me. One of my dear family member, actually my own father, he slipped at his home and he fell and most probably hit his head, and there was nobody around to attend to him, so he couldn't survive. By the time anybody reached there, he was already taking his last breath. So that was a personal shock to me, and I went around looking for a device at that time. What I wanted to do is that whatever accident had happened to should not to my father should not happen to anybody else in family. That was my thinking. Should not happen to my mother, my uncles, my anybody for that matter in my family. So I wanted to build an intelligent device, Daniel, that could inform or that could detect if somebody falls or somebody has more severe problems like getting attacked or getting asthma attack and things like that. So I went around looking for a device that could do so. All the devices available. This is end of 2017. All the devices available at that time, they either needed to be pushed. I mean, they were all brick-sized devices that need to be pushed, that need to be put into your purse or in your pocket. And if you get into some kind of trouble, you push a button. But then when I started thinking about it, if I was to give it to my mother, for example, the device had, if some person has fallen, then the probability of that person pushing a device or pushing a button can be very low. So this device had to be automatically triggered. Also, there were expensive devices that were coming up in market at that time, but they needed charging every day or every 2 days to keep functioning. I imagine that in my case that would not work because any device that needs to be charged, especially elderly people, don't get time or they don't have enthusiasm to keep charging them. So there had to be a device that could detect these problems, that can be worn with a person, can be also always available with a person, and it can run for a very long time on a very small battery. So a very portable, very long lasting battery life device that is intelligent, Now, because I was working for a company that was doing AI chip, I knew how AI worked, and I did know that this could solve the AI problem. So, as I said, I went around looking for such a device, but such device was not available. So we started this company to start designing a very low power intelligent chip, very low power AI chip that could be worn as a pendant, Daniel. I'm happy to say that after 6 years of very hard work, we have that pendant today, and very soon I should be gifting this to my family very soon. Um, that will be capable of doing this type of functions, detecting problems, detecting fall, detecting asthma attack, detecting if somebody is getting attacked automatically without any prompting. So that is how we started Ambient. Now, when we started doing so, designing a chip or building a chip, Daniel, takes a lot of money. That means we have to build a company that is viable business wise. So we started to build a microprocessor, which will be a very similar to a GPU in capability, but consumes very less power. So much so that I can build an AI chip that can be worn as a pendant. So we ended up developing this technology, and now I'm glad to say that we do have this technology that can scale to very small device, and then can also scale to a very large device. And we have a very viable next generation of what you would call AI computing, or next generation of GPU technology that we have developed. And we will not only solve my personal problem, but hopefully solve a bigger problem of power consumption in intelligent computing or AI computing in general.
Yeah, very interesting story. So let's talk about your recent press release. Can you tell us more?
Spurs is called Spurs AI module. The name is actually a Sanskrit or Hindi word, which means touch, Daniel. And this module is that module that I'm talking about, that will be the core compute module within Pendant. This module uses multiple sensors to detect a fall activity, and we are already working on the software or the algorithms that will also detect other activities for human activities, like walking, like sitting, like being idle, like running, falling. Again, we talked about asthma attack, we talked about the fall detection. This module has all this capability. And Daniel, actually, we are finding very interesting applications of this pendant that we had ourselves not imagined. And our customers are able to build their own software using this module for their own applications. So think of this as being your intelligent personal assistant that can help you in many of the emergency conditions. It can help human beings, but also can help machines detect predictive maintenance, or can do some other advanced AI computing work.
Oh, interesting. So how is it so low power? What applications can be developed using this?
So, Daniel, making you may already know that making AI low power is actually almost like a paradox. AI computing takes more power than non-AI computing or generic computing. So we had to develop the technology at very deep layers. We went all the way down, and Daniel, to inventing our own circuits that are able to do the core mathematic functions that AI computing requires. Those are called matrix computing. Then along with that, we solved two other problems, which will be the data transfer and operand transfer. And we solved these, Daniel, at the core circuit level. Means the circuit blocks themselves are able to perform uh, almost 95-99% of these functions without needing help from the software. Now we take this technology that can do lots of this, what is called matrix computing, and then put our own instruction set on top of that and build some generic computing, or what you will call generic SIMD computer, single instruction multiple data computer. We bolt that together and we end up building a core. This core is very much like a GPU core, and it can run instructions. What it means is this one core can be an independent AI computer all by itself, and it can implement any algorithms that an application designer wants to build. We have, and then we can replicate these cores to many times to build a larger and larger device. Like for now, we have a 10 core device. We call it GPX10, which is basically 10 AI cores bolted with some the other generic CPU cores and with other sensor fusion structures to make it an SoC for what you'll call intelligent IoT applications. We have some example applications already. We already talked about human activity recognition. We have voice detection, key word phrasing, or the keyword spotting applications, phrase detections, natural language processing. We also have what you'll call predictive maintenance for machines. There is a customer that is building production assembly line equipment, which will detect if there is any fault in the production line, or there is fault in the item or the mechanical item that is being built. In this case, for example, for wire bonding of an electronic chip. So they're able to do so using this chip. The point I'm trying to say is that it's a programmable chip and it can build many applications. Some of them are being provided to customers by Ambient, by our team, but the customers can also build their own applications. We have a complete tool chain which will allow the customers to build their own applications. One of the features of our first chip is you can connect many sensors. Daniel, we can connect up to 20 different sensors. So we can do very intelligent sensing using our chip. Can be used in monitoring health, monitoring activities, or detecting activities, monitoring machines, monitoring environment. Actually, one of the customers just purchased a development kit, and they're monitoring birds, Daniel, using our chip.
Very interesting. So can we just take this up a level? Can you tell me how is it different from the various edge AI and MPU chipsets that we see on the market today?
So there's a very good question, Daniel, by the way, because there are a lot of people who claim they are building edge AI solutions. They're building either in software or building in chips. Now, in most of the cases, you will see that there is an edge AI chip that has been designed for a particular application. So let's say there is an edge AI chip that can be used for detecting voice or detecting a phrase or detecting a wake word. But it can work for sound, but it cannot work for any other type of sensors. Some of the chips can work for 2 or 3 different type of sensors, but they don't have as much programmability. They're only designed for application. Then there are other type of chips, Daniel, that are programmable, wherein the user can design their own application using these programmable chips, but then those chips consume a lot more power. So in the market, you will see a lot of edge AI solutions. Either they have limited capability or they consume a lot of power. To best of my knowledge, we are probably the only chip or only solution available, Daniel, that has the programmability, but the power consumption so low that this can enable battery operated devices. When you take our core and multiply it many times, in future, we actually are working on such a project right now, but in future you will be able to do as much computing in a laptop or in just a tablet form factor, Daniel, that today you require a complete big server or even chassis to perform. So we build a very efficient and yet very flexible programmable chip, or programmable technology. That's how we are very different from most of our competitors.
Okay, so what is the core technology or the architecture invented by Ambient? How were you able to crack the analog computing when so many others have failed?
It's kind of a very good question, first of all, rather difficult to answer for me because, when we try to answer this question, we start sounding arrogant, Daniel. So forgive me in advance. But yes, there have been other companies who have tried working on this technology, this so-called analog AI computing technology. In our case, Daniel, okay, so let's first understand the problem that we have with the analog AI technology that most companies face, or most of our competitors who tried such things faced. Analog can be very difficult to design, number one. Even after being designed, once the chips are manufactured, they can have unreliable results. So our team and me, through the experience that have had in past, we understood this boundary of analog or the limitations of analog very well. So we have modified some very sensitive parts of analog, Daniel, to make them digital. So in other words, we are kind of developed a hybrid technology that is between analog and digital. It's not entirely analog, not entirely digital. It takes a very middle ground. But in doing so, we have been able to preserve the 80% of advantage of analog, that is the efficiency of analog, but we do not suffer from the reliability or some of the variation problems that the analog design does. So taking this hybrid approach and knowing exactly where the boundary of what works and what does not work has given us this edge where we have been able to do so, and some of our competitors or colleagues may not have succeeded.
Okay, and what kind of products can be created using your technology? And does it scale all the way to larger chips?
Yes, Daniel, it does scale all the way to larger chips. We are already working on products in 12 nanometer and also in 5 nanometer. And we already have signed up projects all the way going to 2000 cores, or it'll even to bigger cores. Daniel, if you allow me, I would like to say, or I would like to put forth that we think we have the solution that will provide the roadmap for AI computing for next 1.5 to 2 decades. This is my thinking, because we as we go, you can see that we are already facing a power consumption problem so severe that there is actually a heat wall or the cooling wall, so to say. We are not able to cool these chips or the GPU based or chips that are there in the market. So our technology would be able to provide the roadmap for next, as I said, 1.5 to 2 decades. Um, I think there may be some other architectures that that are there that might be as efficient, but I don't know about them so far. So we think we are pretty much the most viable solution to provide this roadmap till the quantum computing or some other computing becomes viable.
So how does it solve all of the current problems for data center AI compute? And what are the benefits? Are we already working on a data center chip? Is your team working on a data center chip?
Currently, we are not working on a data center chip, but we are working on a chip that will go into edge servers or the edge compute devices, but it will provide more performance than a data center chip does today. But then again, we are talking about 2 to 3 years from now, when most of this data, or a big portion of the data center AI computing, Daniel, would have moved to edge anyway. So this is an edge data center capable device, but we think by the time we reach there in next 2 to 3 years, the edge computing would have come, or a big part of edge data center computing would have come out of data center into the edge anyway. So what I'm trying to say is we are working on a chip that will be deployed in edge in next 2 to 3 years. And while it is capable of working in data center, we will find a much better application and we'll find much better usability of the chip in the edge itself. We'll have larger chips to go into data centers, Daniel.
Okay. Last question, GP.
Please.
Any predictions for the future of the semiconductor and the compute industry? How do you see this unfolding over the next 5 or 10 years?
So I personally think, Daniel, that in semiconductor, the fundamental innovations that we as the industry have not done is in material science, mostly in material science. That means only the new material will make a very dramatic change in the computing industry. For next 2 decades or even 3 decades, my personal prediction is that we would still be relying pretty much on CMOS. As back, I think as 4 or 5 years ago, I had written an article which in LinkedIn, Daniel, that said that we would keep scaling the CMOS technology, going all the way to around 0.1 nanometer. I still believe that will happen before the quantum computing really comes, if it comes.
Well, it was a pleasure meeting you, and thank you for your time.
Thank you very much, Daniel. I very much enjoyed talking to you, and it's an honor to be here.
That concludes our podcast. Thank you all for listening, and have a great day.